folks. Very welcome. Here we are on the Trelis live stream. We're going at 5 o'clock Irish time every week. So that's about noon, time for lunch if you're on the East Coast in the US, or I think 9:30 if you're in India. They're my reference points. If you're just joining, let me know you're in the chat. Let me know of any questions you have, and maybe we can get through a few of them. All right, we have a few things I'm going to cover. I want to see if anyone has questions on the latest video, which is about representation fine-tuning and fine-tuning with Lora using a tiny number of parameters, like 0.0004% of the parameters tunable. And then I want to cover the IDEFICS. This is a multimodal model. I think it's probably one of the strongest open source models. I'm about to do a video on it next week. And it's now supported by TGI for inference. So you're able to get a text plus speech model running on TGI, and I'm going to show you that today. I have a one-click template that I put up. I've actually been fine-tuning the IDEFICS 8B model today because I'm getting ready for my video. Hey Yugi and Explorer, thanks for joining. Let me know if you have any questions there. I'll pick a few questions during the start of the stream and maybe answer them along the way. Maybe later then, I want to talk a bit more about transformer architectures. So one of my goals over all these videos is to try and build up a transformer model from scratch. And I've been thinking about a few use cases for that. I actually built a little model for predicting the movement of stock prices. And I've been thinking about a little model for predicting the weather based on a past series of weather events. And yeah, the motivation is to try and explain how the different parts, like the feed-forward networks, the attention work, and how you can pretty easily build these transformers from scratch with the help of ChatGPT. If you were listening to the video that I put out this week, it's on fine-tuning with a tiny number of parameters. You might recognize this slide here. I took some time to go through in very simple terms how a transformer works just by describing a two-layer transformer. Nice, Yugi. You have some questions in TGI? Yeah, throw them out. Unsupported models. Yeah, let's talk about that. Hi, Gautam. Can you deploy multi-agent system for high throughput? Okay, we can talk a bit about multi-agent systems as well. Anyone else want to throw in some questions? Because what I'll do then is I'll get started on this TGI question. So you can keep putting in any questions, and I'll kick off there with Yugi, the question on when you can put in unsupported models. So I classify unsupported in two ways. One is fine-tunes of existing models. Can you deploy on TGI, say, a fine-tune of Llama 3, or for multimodal, can you deploy a fine-tune of a model like IDEFICS that we're going to show today? And the answer is yes. You can generally deploy fine-tunes. Can you do unsupported models? Well, I mean, by definition, if they're unsupported, you can't do them. But if you have a model that has got the same architecture and different number of parameters, so say, for example, it's a Llama 2 type model, but you have some variance in the embedding size, but you still have the same attention architecture, I think you can probably get those models to work. So you're not so much changing the architecture, but changing the number of parameters in part of the architecture. So that I think will work. But now if you start talking about completely changing the architecture, like changing how the multi-layer perceptron is working, then that's going to be pretty tough. Hey Loic, salut. So yeah, I think unsupported, if the architecture is the same as a given architecture that is supported, you can, but otherwise I think very difficult. And yeah, Explorer's asking which inference library. So basically there are two really good inference libraries. One is text generation inference by Hugging Face. The other is vLLM. They are both Apache 2 licenses. That was different before for TGI, but it's gone back to Apache 2. So there's no difference in terms of licensing. In terms of performance, they basically have very similar speed. I've been looking at different graphs and they basically have the same speed. The only difference I see is that TGI includes speculative decoding. Sorry, TGI includes flash decoding. Flash decoding allows you to more quickly do inference on very long sequence lengths. So if you have very long context, flash decoding, which is a bit like flash attention, it's kind of the mirror image, but for long sequences that you're going to run for inferences, flash decoding gets you better speed. So basically TGI, if you've got very long context, is probably going to be better than vLLM, but in all other cases, they're going to be similar. There are a few like specific use cases for vLLM. I think there are more people that will build random packages. For example, vLLM lets you apply Loras at inference time. So you can apply on the fly a different Lora adapter to every single prompt within a batch. It's something I'm hoping to make a quick video about actually. There's a little bug that I'm finding in loading the Loras, but that's just an example of where vLLM, because of open source development on it, it can get more specific in the applications. But very broadly, vLLM or TGI. There's also one called Tensor T. I don't know how you pronounce it, but it's Tensor, Tensor T, I think. It's the NVIDIA one, and it's more recent. You would think NVIDIA would have the best inference software, but yeah, is it the most performant? I think because it's new, it's probably not quite as good. Well, not because it's new, because I've seen the evals. It's not quite as fast as running TGI or running vLLM. It's not particularly far off. But yeah, I can just show you actually. I think if I look back at my profile here, there should be a tweet from some point last week. Yeah, actually, look at this graph here. Basically, this is vLLM here in magenta and TGI, and then TRT is Tensort. So yeah, you can see the Tensort is maybe a little bit slower. There's not that much difference. Like these three here are all basically outputting the same numbers of tokens. What you can't see on this graph though is you can't see the context length. The context length is fixed, and that would be interesting to see because I think that TGI would perform a little bit better. I guess vLLM and TGI, they both are very optimized for CUDA architecture, so that's maybe why Tensor RT can't outperform it. Yeah, thanks Yudi about the reft. So let's go ahead and let's get started on deploying a pod to inference a multimodal model. So this is actually kind of tricky normally, because if you're doing multimodal, you've got to input image information, not just text. And all of the inference platforms are built around text. So it's kind of cool if you have one that is able to support images as well. And there aren't that many cases of this working too well, but IDEFICS works pretty well. Let's just quickly look up IDEFICS 8B. This is the model that has just been released a few weeks ago. So it's a second edition. It's built by Hugging Face. It's a combination of two models. I think it's a Mistral text model combined with a SIGLIP model from Google. So it's got a SIGLIP vision encoder. And it's about 9 or 8 billion parameters. So it should run fairly fast, as you'll see when we test it out. And yeah, I'll be going through the fine-tuning this probably in a video late next week, but we're going to take a look already at inference. So here you can see this is the Google SIGLIP model, and then it's based on Mistral as well. So let's move to inferencing this, and we're going to do it with a one-click template, which I'm going to get from the one-click LLMs repo. And I'll drop this into chat as well if you want to check it out later or follow along. So here you can find one-click templates for RunPod and VastAI. You can also find templates for both TGI and vLLM, and there's also a custom API if you want to run Moondream. We're going to use the template for IDEFICS 2, the 8B model, and I've just clicked on that and it'll bring me into RunPod. And that template should now be set up. So all we have to do is select, we just have to select here the A6000. And we're pretty much ready to go now because it's all loaded. I'll just give you a quick look at what's inside the template. So we're going to be loading this model ID. And we're going to set a max input length. I like to set these just so that we don't use too much VRAM. And I also like to turn on speculation. It's a basic form of speculation that guesses a few tokens in advance, and it gives a little bit of speed up unless you're running really large batches. So with that, we'll deploy it and we'll head over to our pods. Now, I want to show you the README here because I've set this up with some easy to get started instructions. So if you just scroll down, let's see here. Have I got the right template? Yeah, I do. It just looks like I didn't update that template, so I'm going to have to do that now. So let's go across and find the IDEFICS template. These chat templates are runpod based templates. These are runpod templates. Yeah, they do make use of a chat template, but they are runpod templates. Now let's check out this README here. And yeah, indeed, it looks like I haven't got this set up correctly. Okay, so everything looks good here. And I thought I updated this earlier, but obviously I didn't. So the normal approach that we would take when we're inferencing or when we set up a runpod endpoint is we get the endpoint running, and then you're able to hit the endpoint via the specific pod ID, which is written here. So I'm just going to type in this test command that we're going to use. I'll just put it into this code cell. We're not going to run it here because it's a code command, a curl command rather. And what we do then is grab the ID. So like this, we grab the API ID and paste that into where the pod should be, like this here. And actually, I think if I submit this curl command when the pod is up, it will respond, even though it's a multimodal model. And the reason is because the multimodal model can accept just text. So you can query it like this, and it should accept just text. But what we want to do is we want to also add in an image. And hi, Pia Dina, you're welcome. You're asking here, and I forgot I can make use of this feature to show the questions. Is there any format that we use to pre-process that data set when we fine-tune Llama? My output is in JSON format. Yeah. Okay, that's a different question. Let me come back to that. I think you're not using the right chat template. You need to go to tokenizer_config.json and take a look at the chat template for Llama 2. Yeah, speculative is a parameter for TGI. It is speculative decoding, and it's a simple n-gram algorithm. So when you edit the pod, this here will give you speculation for 3 forward tokens using simple n-grams, which means it will take combinations of tokens from the input prompt and use those to project forward. So let's check our logs and see how this is doing. So you can see it's downloading the model right now, and we're downloading the third model, the third shard. So that gives us some time just to fix up our prompt here. And what we want to do now is make a copy of this prompt that's also going to allow us to take in an image. So basically, in addition to feeding in this text here that says inputs, we want to put in something that's going to allow us to put in an image right here. And ideally, what we want to put in is a URL to an image. So something like this here. Now, to figure out that syntax, I had it earlier, and I thought it was copied on my pod, so I'm going to have to find it again. And I can find it because I have it in my advanced vision repository. So let's go across and take a look here. And I'll be able to copy out a tip from here. So this here is actually the syntax for injecting the image. I know the font is a bit small, but basically we need to put in these square brackets, and then we need to put in the URL. So it's going to look a bit something like this. And inside for that URL, we're going to put in a URL to an image. And I'm going to just grab an image here. And you could grab any image that you want and post it in. Let's just take a look at what that image is. So it's 2 cats and 2 remote controls sitting on a couch. So let's see how that goes. All right, looks like the pod here has got some more shards loading. So all the shards are now downloaded and we're just waiting for the API to be ready for us to hit it. Now, I think this here is almost what we need. There is, I know, some prompting that we can apply to it. And I'm just going to test out the prompting by running here. This is going to fail because I'm not actually hitting an endpoint, but it is going to print me out my test, my template. So yeah, this is the template we're going for here. It actually starts off with user. And then if you want to put the proper formatting, like the chat templating that the model is expecting, you can go the whole way. So let's actually just copy that. And here you can see that the chat template is expecting user to be at the start. So I'll put user there. And then we have this image being injected. So this is how we're injecting the image into the server. And then we're going to put this end of utterance here just to close this off. And we're not going to say what is deep learning. We're going to say what is in this image. So our curl request is looking good. Got to drop the brackets. Yeah, I think I did. So this is looking a bit better, thanks to Leak. Hey Seb, you're telling me about the advanced API repo. Which one is that? The advanced inference, probably? Yeah, sounds like you're trying to run the OpenAI endpoint. You know, you can post issues. If you've access to the paid repos, you can just create an issue. And I'm usually pretty quick at responding. So probably by now our endpoint is up and running. It is, in fact, because you see the GPU memory is up to the max. Does that mean we're using all the GPU memory? Actually, no, it doesn't. The way that these inference, that TGI and vLLM work is they segment the available VRAM before you run any inference, and they break it up into little chunks, and they assign those chunks numbers. This is called like paging or virtual RAM. So they'll assign them buckets, and then kind of dynamically they can use those buckets during inference. And by indexing the memory, it allows them to be a lot more efficient in dropping memory that's no longer being used. So actually the memory being used is much less. Like this model is probably, when it's loaded, I'm guessing maybe 16, 18 gigabytes. And this is a 48 gigabyte server because I'm using an A6000. So there's no way it's taking up all the memory, but it's just pre-allocating the memory. A quantized version in RunPod. Yes, we can talk about how you would do that. I like this question. Have you loaded a quantized version? Let's talk about that in a sec. But first, let's open up a terminal and let's start hitting this endpoint. So I'm just going to minimize this screen a little bit, and let's start hitting this endpoint. All right. And here's my terminal. Now, let me bring back my screen here. I'll come back to your question there, Yugi, because that's good on quantization. So I'm hitting now the endpoint just with this, what is deep learning? And you can see that when I hit the multimodal endpoint, it actually did respond just with text. So that's good. Deep learning is a subset of machine learning. It's used to solve complex problems. And you can see the sentence is like broken before it hits the end. That's because we've put in max new tokens of 20 here. So that's why it's stopping right there. Welcome anyone who's joining. We're just taking a look at how to inference a multimodal endpoint. And I've just hit it with a text request, but I'm now going to hit it with a vision request as well. So let's see if this works first shot. We've that picture of kittens on the couch. What is in this image? All right, looks like that did not work. So what have I got wrong here? Let's check back with my other sample. So we're going to go back and have a look here. Images. Okay. Let's go back to the terminal. Now, I need to think why exactly this isn't injecting. Have I got my brackets right? I think I do. Well, one thing I can do to check in the meantime is I can actually just hit this endpoint. And I'm just going to put in the pod ID here. So let's put that in. We know the pod is working because we were able to hit it with a standard text request. So here I'm basically doing the same thing. I'm going to hit it with this text here and see if this works. So tell me about this image. In this image, I see a dog and a cat are sleeping on the couch. So that's what the model thinks when we give it this image here. So definitely not a cat and a dog, but it's pretty close. So you can see this is definitely working when we're trying to hit the endpoint. But for some reason, I'm not exactly getting the answer I expect from the inputs. Let's just adjust our request that's going in. So I'm not getting the answer when I directly hit the API, but I am getting the right answer when I hit it with my repo. So let's try hitting it here again. Terminal. And we're not having any joy here. Now let's just see, am I hitting the correct endpoint? I'll check this one again. I think I am. If not, we'll just move on. And I'll put it up as an update in the template so you can check it out later. So yeah, here we are generating text. Whereas here we're not. Let's try doing it without I wonder if it's to do with the formatting of how I'm putting in the image here. So 2 questions there. We have Piadina increasing the max tokens during so if you increase the max tokens, this means that the model will keep generating until you hit that max token amount or until you hit the end of sequence token. So yeah, I mean, really, you shouldn't ever be hitting your max tokens because that means it's going to be abruptly cut off, and that's not something you want. You generally want it to stop when you hit the end of sequence token. So the only reason you set it to short is usually you just want to do something quickly and you don't want to wait. You just want to test that it's responding, and that's kind of what I'm doing now. So you can see that if I put it to something longer, like maybe 200, I'll be able to get a full response about deep learning like this here. But yeah, you can see it's slower to respond, and yeah, it's actually giving me an even longer response. So maybe if I go to 500, we could see if it ever stops. Now, if you do this, you start getting into the question of whether you've correctly set your stop token. I haven't seriously looked at that, so you can see that was pretty fast. Yeah, so even still, it's still blabbing on with a really long response, and it looks like it's repeating. So you can see that the model is repeating what it's saying. Maybe this is an example of why you might not want to use a multimodal model for just text responses. I don't see a stop token, so it seems to be repeating, and it really should be putting in a stop token. So that's not ideal behavior really. But yeah, that's what the parameters, the max new tokens, will do. Yeah, a Docker image for RunPod that we can customize. Yeah, so actually this is a Docker image and you can customize it. So if you start off with any template, it's going to be built. I'm in the wrong Docker image there, but if you go into the one for the one-click LLMs, these are based on Docker images. So you can see this one here is a text generation inference Docker image. It's been pushed to the GHCR of Hugging Face. And this is the way that you customize it. So yeah, I don't know if you have something else in mind for customizing. Like, you can let me know, like, what features are you thinking of customizing, and I can maybe let you know what you would need to fix that. Does it mean it's not instruct fine-tuned? Yeah, that would be like my first guess. Sorry, I'm swapping between comments. That would be my first guess, but no, I think that the model is instruction fine-tuned. It's a bit misleading, but actually the way they've done it is the base model is the one that's not instruction fine-tuned. So yeah, you can see, where is it? Yeah, the base is the base model. This one here is instruction fine-tuned. And actually, if you look at when I ran the inference here, you can see that it correctly finishes. So in this image, I can see a dog and a cat are sleeping. So yeah, this is properly fine-tuned, and that's why it's actually stopping rather than giving us the max tokens. Because I think here I've set the max tokens to, how high have I set it? I've set it to 50, and it's definitely not producing 50 tokens. It's just stopping when it tells us that it sees a dog and a cat, which is pretty close. But as we saw in the image, it's actually 2 cats. So yeah, anyway, you can see that basically to inject the image, you need to put in this, this kind of format here. Now, let me actually go up and see. I'm going to try once more this raw prompt in case that works. And if not, I'm going to fix it in the README of the RunPod template later on. Sorry, I first need to put that into my template. So I just need to paste that into my curl request here. And now I'll copy this. And let's see one more time if it works. So I'm still not generating any text when I directly make a request. And it's most likely because I just have something incorrect in how I'm prompting that. It could be as simple as not wrapping. I'm not sure if this is a sensible thing to try, but I'm not able to generate. That's fine. So I've put the link in the chat, and after the live stream, I'll head over and I'll update the template. So when you go on later on, you'll just be able to check the README, and I'll make sure this here will already work if you put in your pod ID, and I'll put in the updated one here so that you can inject an image here in beforehand, and everything should work fine for you. All right, let's head back to our agenda. Maybe answer a few of these quick questions here. Yeah, I think PAD and I've answered your question, but let me know if you've any more on that. Now let me go back here and talk about the quantized versions. So yeah, actually any model that you're running on TGI, you can easily quantize it just like this. So you can put in quantize, and there are a few options. There's EETQ, which will give you 8 bits. This is a very good option because it's good quality, and also the kernels are fast. So it's basically optimized for CUDA. It's optimized for the interior of the GPU. Another option is bits and bytes, and you can do NF4, and this will do a 4-bit quantization. So this will give you the smallest model, so you can fit it onto a smaller VRAM. But the problem is that when you quantize, actually the computation doesn't happen in quantized form. Those quantized numbers are dequantized, so they're expanded out, and then in the GPU the calculations happen. And that's not an optimized process. There aren't kernels, so there aren't like specific efficient mathematical functions that are being used to run the calculations from the quantized state. So basically what I'm saying is this is slow. If you do BMB, it's going to be slow, and that's a problem. So bits and bytes is kind of cool if you're training, but it's kind of a problem when you're inferencing because it makes things very slow. Even ETQ actually, it won't make things very slow if you're just running a batch size 1 or 2. But if you do batch sizes of 8, 16, even ETQ is going to get slower. And also ETQ is going to be slower to load the shards because it has to set up the quantization, so it can take quite a while to load the model. Now, the other option is you can go for something like AWQ or GPTQ, but those ones you can't do on the fly. You have to actually go to a specific AWQ model on Hugging Face and download it. And that means if you're fine-tuning, you need to fine-tune, and then you need to quantize and upload your quantized version. So it adds a significant extra step. On the plus side, AWQ is a lot faster than bits and bytes. So that's going to be good. GPTQ as well, although GPTQ is kind of slow. Now, there is another library called Marlin that will run GPTQ. This is not how you would do it, but it'll run GPTQ models with the help of, I think, vLLM. And that is probably the fastest way to run quantized models right now. So if I were to summarize, if you really want to quantize, the best thing you could probably do right now, I think, is GPTQ with act order turned on. That's a parameter during quantization, and then run Marlin. That would be the best quality, best speed way to run quantized. The quality will actually be better with bits and bytes NF4 probably, but the speed is bad. And yeah, I should say that I don't think it makes a ton of sense to quantize for inference unless you're running on a laptop or something. The fastest inference is from BF16 models, so I'm just running in 16 bits or FP16 either. And that's where you get the good quality, and all of the GPUs are optimized for 16-bit inference. So I think that's probably the way to go, rather than focusing too much on quantization. All right, what else have we got? It would be cool to try some semantic search live. Yeah, like RAG, is that what you mean? Kind of like vector search? Some vector search? Let me know what you're thinking there, Joao. Yeah, does the model work well with quantization? You mean quality, like perplexity? Yeah, I mean, it's a problem. That's why when I fine-tune models, and you'll notice even when I do tutorials on YouTube, I'll fairly rarely turn on QLoRA, just because I think there's always the unknown of whether the quantization will affect the quality. And if you're going to produce a model that you're trying to sell or something, you probably just don't want to take that risk. You want to do it in 16 bits if you can. Pay extra for having more GPUs while you're training. I mean, usually fine-tuning, you're not going to train for very, very long. And yeah, you can't go backwards. If you train a BF16 model, then you can always quantize. But if you train a quantized model, once you try go back up an upcast and then re-quantize, you're going to lose precision by adding steps. Is CNN also quantized? Convolutional neural network. Do you have a specific CNN in mind, Loic? I'm not too sure. It could be. I've never run a CNN, so I'm just saying it could be, because mathematically it could be. Yeah, Joao. Yeah, a vector search with some LLM. Yeah, that could be interesting. It could be interesting. We could maybe like strip off, say, the first layers in a Llama 3 model and use that as embeddings or something like that, or deeper layers. Fine-tuning is all right with quantization, but not inference. What was my point there? Yeah, well, my point there is that if you use QLoRA for fine-tuning, especially if you're using a library like Unsloth, it actually doesn't slow you down too much. Whereas I think speed is very important for inference. So the fact that using bits and bytes NF4 slows you down by 2 to 4x, that's kind of a problem for inference, I think. Now, quantization during fine-tuning will affect your performance as well, and it can be a bit unpredictable. I think there are some techniques like LoftQ, or even maybe using Dora instead of Lora. These are ways that you can improve quality of using a quantized approach. See, the thing about training with quantization is you quantize the base model for forward passes, but the adapters that you're fine-tuning, so those are actually still in 16 bits. So if you're applying adapters to, say, the O projection or K projection, your adapters are still actually in pretty good precision. It's just the base model that's being quantized. So in principle, you do have kind of a little bit of finesse on the adapters. You've got some precision. But the problem is when you initially quantize, you do lose the base model accuracy. And methods like LoftQ, what they try and do is they try and initialize the adapters so that you compensate for any loss in the model quality when you initially quantized it. And in theory, that's possible. Like, you should be able to pretty accurately compensate for the quantization loss just by initiating the adapters correctly. In practice, though, it's kind of hard. I found it hard to make the LoftQ work as well as doing something like full Lora. In IDEFICS, is CNN quantized in IDEFICS? I wonder if you mean the vision transformer model, like the vision part, like you're asking if that can be quantized. Yeah, I believe that is quantized. It's a transformer network as well, and you can just quantize it in the same way. So are you telling me to use Lora instead of QLoRA? What do you think of Lora versus ORPO? Which is better? This is a good question here. I like this. Yes, I think you probably should use Lora instead of QLoRA if possible. I think it's just more robust. It's more likely to not lose quality. So if you can afford the GPUs or renting the GPUs, I'd recommend just doing Lora. What do you think about Lora versus ORPO? So you can use Lora with ORPO. They're actually two separate things. A different way you could ask, or a different question you could ask is, what do you think of ORPO versus supervised fine-tuning? ORPO is a combination of preference fine-tuning plus supervised fine-tuning. So yeah, you can think of ORPO as a 2-in-1. It does two things at once. One is it does supervised fine-tuning, which uses cross-entropy loss to update the model. But the other thing it does is it will take a preferred and a less preferred answer, and it will drag the model away from the less preferred and towards the preferred. So it achieves what is also achieved by reinforcement learning, or PPO, or DPO, or IPO. Those are all techniques to move the model towards preferred answers rather than rejected answers. But ORPO is a really nice one. It just seems to be robust. And because it literally mathematically combines SFT, the cross entropy loss, with preference fine tuning by basically moving the weights of the model statistically towards preferred answers and away from dispreferred. So yeah, ORPO, I'm a huge fan. I think ORPO, if you have preference data, makes a lot of sense. You save doing SFT and then having to do ORPO. You just do ORPO in one shot. I think it's really good, because previously I did a video on DPO, and you can check that out for preference fine tuning. But DPO is kind of unreliable. Sometimes it would make the model worse, and you still have to do SFT before. But ORPO, I'm a huge fan. And Lora, I'm a huge fan. Lora, it's not just that it saves you massive VRAM compared to full fine tuning. It adds, because it's doing a more averaged update, because you're training these adapters rather than the granular model, it's kind of more robust because it adds some smoothing. And I think you can get faster convergence in a lot of cases with Lora than full fine tuning. It's with model with a CNN part like IDEFICS. My question on quantization. Yeah. Let me know if you know of a model like with the CNN, and I can take a look at it. IDEFICS, yeah, there are two main parts. There are actually more than two main parts. There's the vision model, there's the text model, and then there's the connector. And the connector is actually kind of large. Well, it's not that large, but it's larger than in Moondream or Lava. There's actually like effectively four transformer layers that are connecting the vision and the text model in IDEFICS 2. And yeah, those also can be quantized. And I believe they are when you're doing the fine tuning. So Yeah, Loic is saying that he uses ORPO on an instruct model, not the base one. Yeah, I mean, generally I recommend if you're trying to do your fine tuning, see if you can start with the instruct model rather than the base one, because like companies like Meta, they've put tons of resources into getting a good instruct model. Now, maybe you don't like the guardrailing and that's a fair reason not to use it, but other than that, there's a lot of knowledge that's been built in the supervised fine tuning step, and they also do some reinforcement learning. So going back to the base model, you're kind of just starting at a level closer to ground. So I think it's better to try and start with an instruction model. So yeah, that's fine if you do ORPO on an instruction model, I think. You could, of course, do it on the base model because it's going to do chat fine tuning for you. But yeah, I think it's always good to try use the instruct model. Okay, Joao's got a good question here. What about Galore and B Adam? Have you tried? So Galore, yeah, Galore is cool. I haven't done a video on it just because I kind of think Lora is enough. Galore is relevant if you want to do full fine tuning. So in full fine tuning, you have massive amounts of VRAM that are required. And the reason is you need VRAM for your model, but you also need VRAM for the gradients, and you also need VRAM for the optimizer states. So if you have a model that's got, say, 1 billion parameters, you're going to need to have 1 billion gradients if you're updating all the parameters. And you also need to have 2 billion optimizer states because the optimizer's in 32-bit, not 16. So that's like 1 for the model, 1 for the gradients, then 2 for the optimizer. So I've got 4 billion parameters now I need to update. And then if your model was in 16-bit, you often need to anyway store a 32-bit copy of the model for the optimizer to work. So you end up having an extra 2 billion parameters. So you could easily have 6 billion parameters that need to fit on VRAM. So there's a massive amount of VRAM if you do full fine tuning. And that's why Lora is so beautiful, because it's just fine tuning like 1% of the parameters. So yes, you need VRAM for the base model, that's 1 billion, but then you just need 1% of that. That's going to have optimizer states and gradients stored. Okay, so Galore. So the reason why Galore is useful is because it helps with the optimizer states. So instead of having 32-bit optimizer states, it actually applies Lora within the optimizer. So you only need a small fraction of the optimizer states. And I believe it applies Lora it actually applies Lora probably to the gradients, which then results in having fewer optimizer states as well. So Galore is a way to use Lora within the optimizer when you're fine tuning all of the parameters. And basically means that the optimizer is not going to operate in like 1,000 dimensions. It's going to operate in a smaller dimensional space, which is probably very sufficient. So yeah, if you're very constrained on VRAM, using Galore probably could be a good idea. It's just, I think in many cases, using Lora is going to be better than full fine tuning, and in which case it's going to be better than Galore as well. The only case I'd maybe use full fine tuning is if I was doing like model training from scratch, or you're going to like do, like say your model has been trained from scratch on 1 trillion tokens and you want to add another 100 billion tokens. And these are massive amounts of tokens. Maybe in those cases, you could decide to do Galore if you want to save VRAM. But yeah, that's already a big task if you're doing that much fine tuning. So at that point, you can probably afford the GPUs. I don't know. Anyway, I hope that clarified a bit on Galore. Yeah, so Llama 2. So if you've Llama 2, it's a 7 billion parameter model times 2, because it's 16 bits, 2 bits, 2 bytes required for 16 bits. So that's roughly 14 gigabytes just for the model. And yeah, because the memory requirements for the gradients and the optimizer are really small, because you're just updating a few parameters, you're going to need order of magnitude 16 gigabytes for Lora fine tuning. If you leave some spare for the activations, like definitely within 20 gigabytes, you could fine tune. Now, when you do QLoRA, that cuts in 4 the size of the model. So instead of 16, it's 4 gigabytes. So you'll only need 4 gigabytes plus activations. So you can probably do QLoRA on a Llama model with less than 8 or 10 gigabytes. That's why the Collab notebooks, which use T4s, they have 16 gigabytes of RAM. Is it 15 or 16? And that's why with QLoRA, you can usually fine tune a 7B model, but it's kind of tight if you're trying to fine tune in full precision. And ORPO, yeah, I mean, ORPO is pretty similar VRAM to just doing supervised fine tuning. You've got the same number of gradients, and you can use Lora for ORPO, but you have a little bit more to store in terms of activations, because on the forward pass, you now need to store activations, not just for the rejected, but for the chosen. So you've got like, it's like your prompt is effectively double because you've got to do both the chosen and the rejected answer. But broadly speaking, it's similar requirements. Yeah, so if you want to model, I mean, yeah, I agree. It would be cool to go through an example training from scratch. Maybe it's something I will try. Like, one idea is I could look at doing a really small model, like 100 million parameters, and just train that. It would probably make sense to train it on something like FineWeb. That's like this nicely clean data set. If you just look up FineWeb on Hugging Face, we can even go here to the Hugging Face repo. Let's see, FineWeb. That was not FineWeb. So in datasets, yeah, so this is a really big data set. I think it's like 40 terabytes. But it's been filtered with heuristics and deduplicated. I want to see if there's a graph. Yeah, here we go. So these are some of the data sets you might have heard of. The pile is a pretty well-known one. These all kind of contain web scraping, plus some of them are books. SNMPajama is another one you might have heard of, or FineWeb. Anyway, you'll see that the FineWeb is right up the top, and this is kind of the score that models are getting if they're trained on the same amount of steps of these different data sets. So if you're going to go from scratch, this is a good way to go. And yeah, maybe I should consider, like, from scratch training a model that's like 100 million. Yeah, see, the thing is, the drawback, like 100 million model, it is going to be trainable within an okay cost, but you know, with 100 million parameters, it's hard to get really good behavior. So maybe it's a good idea. I'll consider that. And yeah, like, I think you're right. I should do more on data sets. So I have this video coming out on IDEFICS on fine tuning there. I think that's a fairly powerful model. That's probably the best option for fine tuning for multimodal now. I want to get out a video on applying LoRa adapters on the fly. I have realized just from talking to different people on the web that, well, also through customers, that there's basically a lot of use cases where you want to have a specific setting for a customer's chat. Like, you want the bot to be specifically tuned for, like, I don't know, finance or friendly or something like this. And it's really nice if you can have some toggles. And yeah, if you have LoRa's that you can apply on the fly, that's cool. But anyway, the reason I'm saying that is just because I have those videos I'm kind of focused on for the next little while. But I think overall, like, data is massively underappreciated. It's we always talk about these fine tunings and LoRa's and everything, but really when it comes to getting good model quality, it's all about generating good quality data. And that's probably why Mistral is so good, because they're able to, I guess they're just willing to put a lot of focus on data curation. And that's resulting in powerful models, even though they don't have the most amount of GPUs. So yeah, like, I think it'd be cool to see the workflow, even if it's on like 100, if it's on 100. LLM to VEC. Yeah, remind me what that is. I need to look at that again. It rings a bell, but I don't remember exactly what that is. LoRax. Yeah, that's right. It's true. There are a few libraries for applying LoRa on the fly. The thing that's important, though, is you need to have continuous batching, because nobody's going to use like an inference endpoint in production unless there's good continuous batching. And I can't remember if LoRax does that, but yeah, I kind of think, you know, vLLM or TGI, they offer these OpenAI style endpoints with continuous batching. It'd be great though if there are other solutions that come out, because So yeah, I need to look back at Lorax. I think I looked at it and I just don't remember too well if it does support the continuous batching. Yeah. Most of the multimodal models out there is not one model. They load visual, audio, and text encoders separately. Yeah, multimodal is a big problem. Like, there's not a lot of standardization, and that's why it's such a pain when you're trying to fine-tune them. And yeah, if you look at my videos on Lava, actually Moondream is kind of nice. Like, it's nicely packaged, even though like there isn't a clear standard per se. But yeah, like Lava is kind of a mess. It's quite hard to work with, and I had to make quite custom scripts even to load the model. IDEFICS is nicely done, I guess, because Hugging Face is the ones releasing it. They just have nice integrations with transformers. But yeah, loading models is kind of tricky. And yeah, you end up putting a lot of work into trying to set them up in the first place. Like, it's not trivial to just push together a text and a vision model, or it'd be vision and then text. It's not trivial to cobble those together. Yeah, instilling data. I do have a video on memorization. So that's a specific thing. And you can actually, if you look at my last video on REFT and Lora, where I just fine tune a specific layer and I fine tune a specific with a really small rank, you can actually encode information just into like almost one neuron. What you do is set your rank really low, just pick one specific layer, one specific module, so like an O projection. And what you can do is overtrain it. So do like 100 epochs, and you will just overfit that specific piece of data or sequence you're trying to build in. And you can get the model to replay back these sequences up as far as whatever its original training length was. So you can code in specific sequences. That's not as good as probably what you're asking for, which is like providing a more abstract understanding where you can ask questions from different angles. That requires you to do kind of synthetic data work. There is one of my videos where I make up synthetic data. It's the memorization one, so that's probably the closest. That's probably the closest you can get to it. Okay, I think I've got all the questions here. Let me know if you've. We're getting towards the end of the stream. If you do have any other questions, I've got enough time to get to them in the last few minutes. So yeah, takeaways from this video: maybe consider doing a from scratch training. Maybe consider doing a data cleaning or generation. There are methods as well where you can use language models to clean the data. I think that seems to be what's used by, say, Meta. When they trained Llama 3, they used Llama 2 to generate or clean a lot of the data. So having some kind of video on that would probably be something smart. How many epochs or steps have we trained the model for? I'm uncertain. If there's a loss. Yeah, so there's not a certain loss at which you should stop, but you stop based on your validation loss. So you've got to have a training set, and that training data should be falling. But you've got to have an evaluation set, and that is a different set, which should also be falling. And once your eval set starts to either plateau or come up again, that's how you know your training is probably over, or you're not going to do any better. So it's not like you're targeting a certain loss. It's more like you want to see when your validation loss starts to plateau or goes up again. And then the second thing you got to look for is just bumpiness in the training. So if you see that your training loss is going absolutely wild, like if it starts at 3 and it's going down to 1 and back to 4 and back to 1 and back to 3.5, like that's very jumpy. And it means that probably you need to use a larger batch size, or if you don't have enough VRAM, increase your gradient accumulation, which will allow for more smoothing. Or you possibly have your learning rate too high. So that's kind of how I think about it. Yeah. Oh, T5. Yeah, I've heard T5 coming up lately a few times. I guess it's a compact model, and that's why it's kind of in favor. Let me just check out my templates here. I was just thinking maybe there we go. Yeah. Basically what I did was I updated the wrong template earlier. So I basically went into the IDEFICS 9B model and I put in the 8B. So that is not a terrible thing to do because I can just make that adjustment fast. And that also means you're probably going to get to see it work. So let's see what, if anything, did we have that we were doing. And let's make sure that I put in the correct pod ID here. Of course, this will be for users to put in the pod ID later on. So here we go with the curl request. Let me copy that into the live stream here. Actually, let me put it below just to see if I did make any obvious mistakes. Let's see. I don't see a huge amount of difference. I mean, yeah, I tried doing that, which is clearly wrong. Well, not clearly wrong, but didn't work. Yeah, I don't know. I was pretty sure I had this working earlier. I don't think this is any different, but let's see what it says. Oh, okay, it worked. So here you go. I've got it fixed now. So if you do go into that, chat way back, yeah, share the URL for all the RunPod templates. Yeah, here you go. Where is it? It's this one here. Yeah. So if you go into that now, and if you go into the README, it's all going to work now. I'll just click save. And to be honest, I don't fully understand what I did that was wrong earlier, because I seem to have almost the exact syntax. The only difference I see is that I have this new line here. Let's just try to put that in. I see a question in the chat, so I will answer that in a second. URL is in quotes. Yeah, it was in quotes, and that was me messing around hoping that I would get it to work, but it may actually just be that that new line is missing. It looks like it is. So yeah, that just shows you how sensitive the prompt templating is. It's really important that you follow the exact syntax of the model, whatever's in the chat template. So yeah, anyway, this is an image of a sofa, and on the sofa there's a dog and a cat. And as we mentioned earlier in the call, this is the image, and that's the response that it's giving. So it is working. I will say, like, it's pretty impressive how Moondream works, because it's a way smaller model than IDEFICS 2, and it's able to get a lot of these questions pretty correct. So yeah. So yeah, that was just a matter of prompt templating. And if you want to, yeah, I guess you've got to copy this in the RunPod README, so you can check it out there. All right, folks, that's it for this week. Keep an eye out for a video on fine-tuning for the IDEFICS model, IDEFICS 2. Actually, I've uploaded the notebooks already for those of you who have access to the advanced vision repo. Anyone, of course, can take a look at that one-click template for the multimodal model. And let me know in the meantime. You can just comment on Twitter or YouTube if you've any questions for the session next week. Definitely taking away that doing some kind of a full from scratch training would be interesting, and also some data set work would be interesting. So thanks for that feedback, and I'll see you all again next week. Cheers.